On January 26, 2013, a band of al-Qaeda militants entered the ancient city of Timbuktu on the southern edge of the Sahara Desert. There, they set fire to a medieval library of 30,000 manuscripts written in Arabic and several African languages, and ranging in subject from astronomy to geography, history to medicine, including one book which records perhaps the first treatment for male erectile dysfunction. Unknown in the West, this was the collected wisdom of an entire continent, the voice of Africa at a time when Africa was thought not to have a voice at all. The mayor of Bamako, who witnessed the event, called the burning of the manuscripts a crime against world cultural heritage. And he was right, or he would have been if it weren't for the fact that he was also lying. In fact, just before, African scholars had collected a random assortment of old books and left them out for the terrorists to burn. Today, the collection lies hidden in Bamako, the capital of Mali, moldering in the high humidity. What was rescued by ruse is now once again in jeopardy, this time by climate. But Africa and the far-flung corners of the world are not the only places, or even the main places, in which manuscripts that could change the history of world culture are in jeopardy. Several years ago, I conducted a survey of European research libraries and discovered that, at the barest minimum, there are 60,000 manuscripts pre-1500 that are illegible because of water damage, fading, mold, and chemical reagents. The real number is likely double that. And that doesn't even count Renaissance manuscripts and modern manuscripts and cultural heritage objects such as maps. What if there were a technology that could recover these lost and unknown works? Imagine worldwide how a trove of hundreds of thousands of previously unknown texts could radically transform our knowledge of the past. Imagine what unknown classics we would discover, which would rewrite the canons of literature, history, philosophy, music. Or, more provocatively, that could rewrite our cultural identities, building new bridges between people and culture. These are the questions that transformed me from a medieval scholar, a reader of texts, into a textual scientist. What an unsatisfying word reader is. For me, it conjures up images of passivity, of someone sitting idly in an armchair, waiting for knowledge to come to him in a neat little parcel. How much better to be a participant in the past, an adventurer in an undiscovered country, searching for the hidden text. As an academic, I was a mere reader. I read and taught the same classics that people had been reading and teaching for hundreds of years. Virgil, Ovid, Chaucer, Petrarch. And with every scholarly article that I published, I added to human knowledge an ever-diminishing slivers of insight. What I wanted to be was an archaeologist of the past, a discoverer of literature, an Indiana Jones without the whip, or actually with the whip. And I wanted it not just for myself, but I wanted it for my students as well. And so 6 years ago, I changed the direction of my career. At the time, I was working on The Chess of Love, the last important long poem of the European Middle Ages, never to have been edited. And it wasn't edited because it existed in only one manuscript, which was so badly damaged during the firebombing of Dresden in World War II, that generations of scholars had pronounced it lost. For 5 years, I had been working with an ultraviolet lamp, trying to recover traces of that writing, and I'd gone about as far as technology at the time could actually take me. And so I did what many people do. I went online, and there I learned about how multispectral imaging had been used to recover 2 lost treatises of the famed Greek mathematician Archimedes from a 13th century palimpsest. A palimpsest is a manuscript which has been erased and overwritten. And so, out of the blue, I decided to write to the lead imaging scientist on the Archimedes palimpsest project, Professor Roger Easton, with a plan and a plea. And to my surprise, he actually wrote back. With his help, I was able to win a grant from the US government to build a transportable multispectral imaging lab. And with this lab, I transformed what was a charred and faded mess into a new medieval classic. So how does multispectral imaging actually work? Well, the idea behind multispectral imaging is something that anyone who's familiar with infrared night vision goggles will immediately appreciate. That what we can see in the visible spectrum of light is only a tiny fraction of what's actually there. The same is true with invisible writing. Our system uses 12 wavelengths of light between the ultraviolet and the infrared. And these are shown down onto the manuscript from above from banks of LEDs, and another multispectral light source which comes up through the individual leaves of the manuscript. Up to 35 images per sequence, per leaf, are imaged this way using a high-power digital camera equipped with a lens which is made out of quartz. There are about 5 of these in the world. And once we capture these images, we feed them through statistical algorithms to further enhance and clarify them, using software which was originally designed for satellite images and used by people like geospatial scientists and the CIA. The results can be spectacular. You may already have heard of what's been done for the Dead Sea Scrolls, which are slowly gelatinizing. Using infrared, we've been able to read even the darkest corners of the Dead Sea Scrolls. You may not be aware, however, of other biblical texts that are in jeopardy. Here, for example, is a leaf from a manuscript that we imaged, which is perhaps the most valuable Christian Bible in the world. The Codex Vercellensis is the oldest translation of the Gospels into Latin, and it dates from the first half of the 4th century. This is the closest we can come to the Bible at the time of the foundation of Christendom under Emperor Constantine, and at the time of also the Council of Nicaea, when the basic creed of Christianity was being agreed upon. This manuscript, unfortunately, has been very badly damaged. And it's damaged because for centuries it had been used and handled in swearing-in ceremonies in the church. In fact, that purple splotch that you see in the upper left-hand corner is aspergillus, which is a fungus which originates in the unwashed hands of a person with tuberculosis. Our imaging has enabled me to make the first transcription of this manuscript in 250 years. Having a lab that can travel to collections where it's needed, however, is only part of the solution. The technology is expensive and very rare, and the imaging and image processing skills are esoteric. That means that mounting recoveries is beyond the reach of most researchers and all but the wealthiest institutions. That's why I founded the Lazarus Project, a non-for-profit initiative to bring multispectral imaging to individual researchers and smaller institutions at little or no cost whatsoever. Over the past 5 years, our team of imaging scientists, scholars, and students has traveled to 7 different countries and have recovered some of the world's most valuable damaged manuscripts, including the Vercelli book, which is the oldest book of English, the Black Book of Carmarthen, the oldest book of Welsh, and some of the most valuable earliest Gospels located in now what's the former Soviet Georgia. So spectral imaging can recover lost texts. More subtly, though, it can recover a second story behind every object, the story of how, when, and by whom a text was created, and sometimes what the author was thinking at the time he wrote. Take, for example, a draft of the Declaration of Independence, written in Thomas Jefferson's own hand, which some colleagues of mine imaged a few years ago at the Library of Congress. Curators had noticed that one word throughout had been scratched out and overwritten. The word overwritten was citizens. Perhaps you can guess what the word underneath was. Subjects. There, ladies and gentlemen, is American democracy evolving under the hand of Thomas Jefferson. Or consider the 1491 Martellus map, which we imaged at Yale's Beinecke Library. This was the map that Columbus likely consulted before he traveled to the New World, and which gave him his idea of what Asia looked like and where Japan was located. The problem with this map is that its inks and pigments had so degraded over time that this large, nearly 7-foot map made the world look like a giant desert. Until now, we had very little idea, detailed idea that is, of what Columbus knew of the world and how world cultures were represented. The main legend of the map was entirely illegible under normal light. Ultraviolet did very little for it. Multispectral gave us everything. In Asia, we learned of monsters with ears so long that they could cover the creature's entire body. In Africa, about a snake who could cause the ground to smoke. Like starlight, which can convey images of the way the universe looked in the distant past, so multispectral light can take us back to the first stuttering moments of an object's creation. Through this lens, we witness the mistakes, the changes of mind, the naivetes, the uncensored thoughts, the imperfections of the human imagination that allow these hallowed objects and their authors to become more real, that make history closer to us. What about the future? There's so much of the past, and so few people with the skills to rescue it before these objects disappear forever. That's why I've begun to teach this new hybrid discipline that I call textual science. Textual science is a marriage of the traditional skills of the literary scholar, the ability to read old languages and old handwriting, the knowledge of how texts are made in order to be able to place and date them, with new techniques like imaging science, the chemistry of inks and pigments, computer-aided optical character recognition. Last year, a student in my class, a freshman with a background in Latin and Greek, was image processing a palimpsest that we had photographed at a famous library in Rome. As he worked, tiny Greek writing began to appear from behind the text. Everyone gathered around, and he read a line from a lost work of the Greek comic dramatist Menander. This was the first time in well over 1,000 years that those words had been pronounced aloud. In that moment, he became a scholar. Ladies and gentlemen, that is the future of the past. Thank you very much.